Welcome all for the happy learning in data structures and algorithm. Today we are continuing with our fifth module, which is about graphs and sorting. Under fifth module, we are discussing our seventh session, which is about searching. The most of our real-time application, day-to-day application, what we are using requires the concept of searching. We need to retrieve a data from a database, and this is done by help of searching function. Here in searching function, we'll be having a sequential data, and among those data, the element required by the user has to be searched, and it has to be retrieved from the database, and it has to be returned to the user. To do this, there are two general techniques. There are two algorithms to implement this searching. One is linear search algorithm, the other one is binary search algorithm. Let us discuss each of the algorithm in detail. First, we'll start with the linear search. This is the straightforward searching algorithm. The concept we have here is, it starts with searching an element from the first element in the list, and it continues until it finds the element in the list. We know that the data is what we store in the database. It will be stored under any of the data structure. Here we are considering the list. Considering the arrays, the data are stored in the arrays, and while we search an element, we will start searching from the first element in the array until we find the element what we are searching, and this will be continued. This process will be continued until the end of the list. Until the end of the list, we will start searching for the key element, and we search this key element with the help of linear function. Okay, it starts traversing from the first element to the last element in the list, and the other name for linear search is sequential search. When to apply, since we have two algorithms for our searching technique, when to apply which specific algorithm is discussed here. Linear search algorithm can be applied when you don't have any data information about the element what we have. When we don't have, whether it is an sorted array or unsorted array, when we don't have the proper information regarding the data, we can go with the linear search, and this can be implemented. Linear search can be implemented when your size of your element in the list is less. Here is an algorithm to implement our linear search. So here we have to start searching from the first position to the last position. When we perform searching operation, there is only two possibilities. Either we'll find an element in the list, or we may not find the element. So we have to check for the condition which falls under any of this category. To check the condition, we are using the for loop, and we start searching the element. That is, we start searching the key element from the 0th element until the end of the array. When an element is found in a particular position, it has to return the size of the position where the element is found. When it continues until the end of the list, even then it is not able to discover the element, then it has to throw the message that the element is not found. For that, we are using a for loop. So initially the array size we are initializing it to I is equal to 0, and we are searching whether in the ith position the element is present. So the key, if key is equal to array of I, what we are doing, if it is equal to array of I, then it will be returning the position. Otherwise, it has to go to the next element in the array, that is I is equal to I plus 1. You will be continuing this until we find an element. If the element is found, the position of that particular element has to be written back. Otherwise, it has to increment the array size until it reaches the end of the array. See, this is the routine for linear search. So in linear search or sequential search, we are going to perform this operation in the array A, and the key is nothing but the element what we are going to search, and we do this with the help of for loop. We start with I is equal to 0 to n minus 1. Since we are implementing through array, it is based on the size of the array. Suppose we have 10 elements, our array will be starting from 0th position to the 9th. To specify that, we give it as n minus 1. To indicate that the last element in the 9 is in the 9th position, we give it as n minus 1. N is nothing but the size of the array. If your element what you are searching is present in the A of I, the particular index will be written. Otherwise it will return -1, that is, it is a false condition. This is what the routine we have for the linear search. And we'll discuss the advantage and disadvantage we have for this linear search algorithm. It is the simplest technique since it starts searching from the first node and it travels until it finds the element. This will be continued until the end of the list. And it doesn't have any, since it is it doesn't have any technique, any other data, any other process to sort that. Since it is an unsorted data, we don't require any of the list to perform the sorting function. The main disadvantage we have is we cannot implement this linear search when your data size is high. And when your data size is high, the time required to search the element starting from the first index to the last index, your time consumption will also be more when you go with an linear search. Now the next technique is binary search. Here the concept behind the binary search is, here we will be dividing our array into 2 subarrays, and the searching operation will be done based on the condition, and it will be done only in the specified array based on the condition. The prerequisite for binary search is that the input what it receives should be in the sorted array. The binary search is applicable only for the case of sorted array. Only when the array is in the sorted, you can implement the binary search. Okay, it follows the concept of divide and conquer technique. As we have already seen in the quick shot, how we choose a pivot element and we given scenario over there, the value less than the pivot element should be should be towards the left, and the value greater than that of the pivot element should be towards the right. Similarly, even we implement a concept of divide and conquer using the concept of middle value. So based on the size of array, first we'll be determining the middle value, and from that middle value we will be checking for the 3 conditions. Only there are 3 possibilities for that. Okay, the element what we are searching, either it may be a middle value, or the element what we are searching may be less than that of a middle value, or the element which we are searching may be greater than that of a middle value. There are only 3 possibilities. So based on these possibilities, we will be performing our searching algorithm. Suppose if our element is at the array of mid position, then directly we'll be returning the value. If the element what we are searching is less than that of a middle value, then we go we ignore the right of, since this binary search follows the concept of ordered list. Only ordered sequentially ordered data we have, so we can avoid the searching technique over the right of the list. Similarly, in the third case, when your key value is greater than that of a middle value, you can ignore the left of your list until the middle value. Hence, the greater value will be residing towards the right of the middle value. By doing so, there is no need of searching the entire element in the list. That is why we go for binary search. It follows the concept of divide and conquer, and each and every time when it is doing, it works with first find out the middle value, and based on the 3 condition it will be executing. And this is the fastest algorithm, and each and every time when it is doing, it will be applying the condition, which condition has to be applied based on these 3 cases. Under what case it falls, only that will be the implementation of searching will be done only under that cadre. Okay, and here it is purely based on the sorted array. It has to be sorted, only then you can implement this binary search. Okay, and how to implement binary searches, when your array is not sorted, first you have to use some sorting technique. As we have discussed, we have many sorting technique like insertion sort, selection sort, bubble sort, quick sort. Choose any of the sorting technique and get the data sorted, and then you can apply the binary search algorithm. So here is the algorithm for that. So first we start the array and initially we initialize our I and I is equal to 0 and j depends upon the size of your array, and k is the middle value. K is the element what we are searching. So I is the starting value and j it is based on the size of an array. What we do is to find the middle value we use the variable k, which is I plus j by 2. I plus j by 2 will return you the middle value, and we will be choosing the sealed value. If it is 4.5, we will be going with 4. After that, we will be checking the condition whether the element what we are searching is at the mid position. That is your first case, or it may be the element what we are searching may be less than that of your mid position. This is the second case, and the third case is the element what we are searching may be greater than that of your middle element. Based on that, we perform the searching operation. Yeah, and the advantage and disadvantage we have here is, here comparatively with that of a linear search, the number of iteration is less as we restrict based on the condition. When it has to fall only under the 3 cadres, and we'll be going with that condition alone, ignoring the remaining 2 conditions. So the number of iteration is comparatively less than that of the linear search, and it is also fastest approach compared to that of a linear search. Hence we use the concept of divide and conquer. And the major drawback we have here is we have to implement one more algorithm to perform the sorting if the data is unsorted. Okay, and the implementation part, when it comes to the implementation part, compared to that of the linear search, binary search implementation is difficult, as it needs first a sorting algorithm to sort, and then we implement we find the mid value and we check out the conditions for it. This is all about our searching algorithm. This is where we have implemented linear search and binary search. Thank you all.